Hey, what's going on, everyone? Let's see. It is August 3rd. Seems like there's a bit of an echo in here. That seems weird. Yeah, anyway. So, it's August 3rd. Um, I didn't record for a while. We were over at my parents' house we were like house sitting for my parents. And so I brought my computer, but I didn't bring all of like the recording setup. So I just didn't record for a while. Today, and actually I forgot to post a video from like 2 weeks ago. So I'm going to upload that today as well. That was still talking about agile software development. Still have some opinions on that. It's kind of ongoing at work, so I'm curious where exactly that's going to go. That echo seems weird. Um yeah, anyway, so what did we do today? Today we woke up. I think I couldn't fall back asleep after like 3:30, so we woke up. We went walking. I think we walked for like 3 hours. And I was listening to a good book. The book I'm listening to right now is actually so over the last 2 weeks, I listened to a couple of different books. I re-listened to So Good They Can't Ignore You. I think I listened to it twice actually, just because I really like that book. I think it puts you in a really good mindset for focusing on skills, things like that, um, and understanding how to get those, like how to increase those skills. And so obviously, well, I shouldn't say obviously. I mentioned it in one of my other videos. That concept of deliberate practice. So pushing yourself, like doing practice, but not just any old programming isn't necessarily good. It's that programming where you are learning and stretching yourself. Or if you're playing guitar, it's that not just playing songs that you already know and can play really well. It's playing songs that push you. So that's that concept of deliberate practice. Let's see. Is there any other key insights that I gained this time? I'm sure there were. Um, Try not to get too unhappy with any particular job. I guess that's basically one of the things that did stick out to me was uh, being patient. And Steve, like the "So Good They Can't Ignore You" is from a Steve Martin quote anyway. But part of that is Steve Martin said, "Be patient." He says like he wanted to learn banjo, and he says, "Well, I just assumed that if I played for 40 years, that eventually I would just be really good at it." And so he says, "This is Steve Martin." He says, like getting good at something is less about like saying yes to that thing and more about saying no to all the other distractions. And so there is a big part in that book as well. But that kind of reminds me of some of the stuff that Gary Vee says as well. He talks a lot about clouds and dirt. Gary Vee does. Um, so like the dirt is getting those skills, but the clouds is kind of like being patient and recognizing that it's not going to happen right away. And so I think that's a big part. Like every now and then, every couple of years or so, peek your head up and see if there's other opportunities, and see if your skills or career capital can get you something more. But recognize that it is going to take some patience. Anyway, so I really like that book. Put me in a good mindset. But I wanted to reread a book called Range. And Range kind of argues almost the opposite, which I kind of like about that. So Good They Can't Ignore You is about gaining skills, but it's also like a lot of the books that I read. There's Peak by Anders Ericsson, the actual scientist who did a whole bunch of like the 10,000 hour rule stuff. Um, Jeff Colvin wrote a book called Talent is Overrated, which talks about that same. It's all that this same stuff about getting expertise in a narrow field. And So Good They Can't Ignore You is focused on using those techniques to get a job that you really love. Range is more about being a generalist. And that's part of the reason I was looking at it as well. I was curious what he was saying. So for example, Tiger Woods was focusing on playing golf. Like he'd been focused on playing golf since he was like 3, but like Roger Federer, I don't know if that's his name. I'm probably saying that wrong. He was a tennis player, but even like at an early age, he was just playing all sorts of sports. And like Vincent van Gogh didn't really start painting until he was like 33, 34, 33. And I think he died at like 37. And so he wasn't focused on painting. So it wasn't just that narrow focus on a particular subject that made them great. I don't know. I don't know if I like that argument. It's still a fine book. One of the things is that he even talks about in So Good They Can't Ignore You is like just because this, like the opposite argument from So Good They Can't Ignore You, just because that works in certain instances doesn't mean it's good general advice. And so that's where I'm kind of torn on that. Of like, maybe it did work for Roger Federer, or maybe it did work for Vincent van Gogh, but it doesn't mean that it's necessarily good advice for everybody. It's hard to say. That being said, I very much feel like I'm a generalist programmer. These days, I've been doing a ton of, well, I don't know about a ton. Still, yeah, I do Android programming, but I also do iPhone programming, like iPhone app programming, and I still do game programming. And we hit on the back end a little bit, and obviously my background was all in games programming and C++, and I don't do that anymore. So I count myself as more of like a generalist programmer, which I think does help me out. I don't know if other people necessarily consider that. So that's something interesting as well. Do other people value that? We talked about in our on our other channel, the other podcast, being a generalist versus generalist versus specialization. And we talked about the concept of a T developer, where a T developer, so an I developer is somebody who is just specialized like down one field. T developer, like I guess down one field, right? T developer, you have some different skills, but you're still specialized in one thing. And then I recently heard people kind of expand on that. They call it a pi developer, like not like cherry pie, but like pi the number, because it's like the inverted, like it's like you're like a generalist with like two combs, or like two legs. Or they actually have something called a comb developer, where you have like a list of general skills, but you have like multiple specializations. I guess you could just call that a full stack developer. I mean, it's possible, but it also seems really weird. I guess as you develop in your career more, maybe that certainly is possible, and I think it's probably required as you become more of like the VP of engineering or principal programmer or whatever. You probably have to be at least knowledgeable about these different domains so that you can hop into the code base and fix whatever needs to happen. If you're like the lead programmer, if you're the lead mobile programmer for iOS and Android, and then all of your Android people are gone, you have to be able to jump in and do bug fixes and build features on Android. Same thing, if you're that same person and all of your iOS developers quit, you can't just not do anything. So you do have to be both, I guess. The other reason we were talking about range, the reason I even started reading it, because we were talking about, also on the podcast, we were talking about AI. And so in this book, he talks about this, not necessarily AI, but just what are computers at, and what are computers good at, and what are people good at. And so computers are very good at crunching numbers, and he actually calls it tactics. The small recognition of patterns and being able to act on those patterns, or like do those patterns like in repetition. And that's one of the reasons why computers are so good at chess, because it is just patterns. So if like given enough games or given enough scenarios, or even things like Deep Blue, where like they learn what works and what doesn't work, they recognize these patterns, and they can they can learn chess. And then because of that, because computers are so good at that, they're way better at pattern recognition and tactics, like small, minute tactics. That's why they can beat humans at chess, because it's fundamentally that is what that game is. One of the things that they talk about, though, is humans or computers are better at tactics, but humans are better at strategy. And so, like, a human computer pair beats a computer. Like, which I guess maybe makes sense, but it's like the human is good at looking, again, maybe clouds and dirt. They're looking up at the clouds. They're looking at the overall picture and kind of focusing the computer to say, hey, go down this direction, go down that direction, and try to find patterns there, and then like kind of guiding and maybe even picking what the overall strategy is. And I thought that was interesting. So computers are going to be good at, like, there's certainly things that they're going to be better at than us. But I don't think it's necessarily that computers are just going to be better at everything. A really good example is the optimization or optimizer on a compiler. Like, it's pretty hard for a human to really optimize the assembly better than, like, I can write C code. I'm writing a very high level app. I'm writing whatever, Objective-C or Swift. I'm writing this high level app to do these very specific, or, to do these requirements that our clients or our the stakeholders want. And I'm writing it in, actually, I'm probably not even writing it in the most efficient way. I'm writing it in a way that's flexible so that we can rewrite it later. That's what object-oriented programming is. Recognizing that it's going to change, I want it to be not just a collection of garbage code that runs the fastest. I want it to be, I want that code design to be flexible so that we can change it in the future or as requirements change. So that's kind of my high-level view of it. And then it goes through the compiler and hopefully an optimizer. And the optimizer, obviously optimizes. It optimizes the assembly. It might take out instructions that don't actually need anything, or it might rearrange the instructions based on how data is going to get fetched from the CPU, things like that, or fetched from RAM and like how it's needed in the CPU. So that also kind of reminds me of the strategies versus tactics. The computer is always going to be better at optimizing, but it might not be better at writing code. I don't know if it's going to be better at writing code in a flexible way. Now, maybe it doesn't need to write code in a flexible way. As we go into the future and the compiler is actually writing more and more code and our computer languages are higher and higher level, maybe the computer writes code so fast that it doesn't need to be flexible, which is fine. But still, I don't think we'll ever get to the day where we can just ask the computer, hey, build me a fitness app. Or if we could get there, the reason I don't think we can get there is because what do you want this fitness app to do? Okay, I want it to log in and save this data to the database. Okay, and then what happens after you log in? Like, what's it going to show? Where is it getting its fitness data from, or whatever? Right. So somebody is still going to have to be telling it where to connect that data from. And if you don't have that, and even if you had all that, so even if the computer was like, okay, here's a standard fitness app with login and has the ability to connect to this fitness database, okay, that app is boring because everybody can make that. If it takes the programmer 2 seconds to say, build me a fitness app that connects to the standard database with login, nobody would use that app. So it's not worthless. It's cool for you. You have that app, but that means nobody's going to pay for that app. Nobody's going to pay for that because anybody can just get it for free. So there's always going to be people using the tools available to push whatever those tools are capable of. So even despite that, there's always questions like, what's going to happen if, I'm trying to think of what's like a situation or a bug we have in our code base. I'm trying to think. What would some situation be? Anyway, there's always going to be these edge cases, and right now it is based on writing or like I'm writing code. Well, even like sometimes some of the data in the database, is different than you expect. So the question is, what do you do when that data is different, right? Especially if it's like changed, if this app has changed over time. Maybe you had an app that only supported inches, and then now you have to support like inches and centimeters, something like that. Okay, so what do you do with all that old data? Do you how do you store it? Anyway, like there's going to be edge cases where the computer isn't going to predict every single thing that you want. It's going to have to make it might make some assumptions, and those assumptions may eventually like have conflict. And the computer could be smart enough to tell you that there's a conflict, but it's still going to say, okay, what do you want to do with this app? So whatever that looks like in the future, that's still going to be the programmer, the one who's explaining, going through in maybe less rigorous detail, but still rigorous detail of what this app or program actually needs to do. That's going to be the job of the programmer. Learning how to interface, like human interface with that computer, and explaining what the app or the program needs to do. So I just think that's always going to be there. I don't even know. I don't know. It's like automation has been a piece of human lives forever, I guess, right? Whenever we make a new tool, we could say, oh, well, now that made farming easier. So what are all those farmers going to do? You just made farming easier. We don't need everybody to farm. Okay, well, now they can go and do something else, right? And so, yeah, I don't know. We'll see where it goes, but I don't think it's a bad thing. Anyway, I think I was just rambling a lot here today. What else have I been doing? I'm learning more about like the preferred Google architecture components. So a lot of what I did in my app, and like I've been kind of doing it a similar way over the years, is I use what I always just called MVC, Model View Controller. Unfortunately, that word got kind of tainted. I feel like it's got tainted by Apple. And so, because they called their iOS platform, they called it MVC. And in my opinion, I don't think that it is. You have two pieces. You have, like they call their, like MVC is Model View Controller. They call one of their components, they just call it the View Controller. It's like, well, you're right there, you're already mixing the two. And that just doesn't seem like that's the opposite of what you should do. So the way that I always did is I had this, I would call the View Controller or the activity as the view, and then I would have my own other controller that handles all the business logic. I always did it that way. These days, everything's being called MVVM, so that controller it's model view model. And so now everyone just calls it that. I'm fine with that. I don't like the name, but that's fine, whatever. But over the past couple of years, Google has came out with some of their own architecture components that work with that kind of setup. And so instead of calling it a controller, they call it a view model. And it works well, this is what I'm learning. It works really well with their activity lifecycle or fragment lifecycle. Now, I built this myself just using an interface, just like everything communicates through an interface, and having like a base class view and a base class controller, and they kind of, like the lifecycle events are mostly handled. I say mostly because I think my onCreate is still probably out of order. I'm not really happy with it, but anyway, so I'm going through and learning the Google preferred way, because I think going forward, I think that's where a lot of the tools are going to be. Like, it's probably better. I mean, I already have my stuff written, but it's still probably better as they tweak their own view model. I get the benefits of those tweaks, things like that. So that's what I've been working on. I'm going to do that. I'm going through some other libraries as well, some Android libraries for like networking. I think that my networking layer is pretty good. We talk about that a lot at work. I think that mine is pretty good, but I know a lot of people wonder, oh, why don't you use Retrofit or OK HTTP or something like that? So, and I just wrote it myself. Yeah. Anyway, I'm learning the ins and outs of these other libraries, just so that I can at least have either make the switch or just have a good argument for why I think mine is better. Anyway, still got about 20 minutes before work, so I'm going to keep doing some studying, and I'll talk with you tomorrow. Bye.